The year is 1896. In the sprawling St. Rolloch's Works of Glasgow, a railway carriage takes shape, not welded, bolted, every joint secured with hand-forged iron rivets and steel bolts, each one tightened by men who knew their names would be stamped on their work. The carriage that emerges will carry passengers into the 1970s, 70 years of service without structural failure. Today, a modern train carriage is considered elderly at 30. This isn't nostalgia, it's engineering. The Caledonian Railway understood something we've forgotten. Permanence isn't expensive when you calculate across decades. In an era before planned obsolescence became corporate doctrine, Scottish railway engineers built carriages designed to outlive their creators. The secret wasn't superior materials. Victorian steel was crude by modern standards. The secret was the bolt. When metal is welded, it becomes a single continuous piece. Elegant, seamless, permanent, until it fails. Then the entire structure must be scrapped. A welded joint creates heat-affected zones where molecular structure weakens. Microcracks propagate through these zones, invisible, until catastrophic failure occurs. Modern carriages are retired not because they're worn out, but because their welded frames have become structural liabilities. Bolted construction operates on different principles. Each connection point remains discrete. Bolts can be tightened, replaced, upgraded. A cracked plate doesn't doom the entire frame. It's unbolted and substituted within hours. The carriage evolves rather than degrades. Victorian engineers weren't building for 10 years or 30. They were building for generations. The 1896 Caledonian carriage weighed 11 tons empty. Under frame, wrought iron channels bolted to cross members at precise intervals. Body panels, quarter-inch steel plates secured with countersunk rivets every 4 inches. Interior skeleton, timber frames bolted to steel brackets, allowing the wood to expand and contract without stressing the metal. Every component could be isolated, inspected, and replaced without compromising adjacent structures. The bolts themselves were forged masterpieces, each one heat-treated to specific hardness levels, threaded by hand to tolerances tighter than factory specifications. Castellated nuts with split pins ensured they couldn't loosen under vibration. Spring washers distributed stress evenly. Lock wire secured critical joints. A single wheel truck assembly contained 48 bolts of 17 different specifications. Each one served a calculated purpose. Assembly took weeks. A team of 6 riveters worked in synchronized rhythm, heating rivets to cherry red, driving them through pre-drilled holes, hammering heads while the metal remained plastic. The sound was thunderous, an industrial symphony that echoed across street. Rolloch's, for 12 hours daily. Quality control was brutal. Every joint was tested under load. Rejected work was dismantled and redone at the builder's expense. The carriage entered service on the Glasgow to Carlisle route in March 1897. Passengers noticed the solidity immediately. No rattles, no flexing. The bolted frame absorbed track vibrations without transmitting them to the body. Springs and bolts worked in harmony, isolating passengers from the chaos beneath. Compare this to modern carriages, where welded monocoque construction transmits every rail imperfection directly into the cabin. By 1910, the carriage had logged over 500,000 miles. Maintenance records show routine bolt inspections every 6 months, with replacements averaging 15 bolts per year, about 2% of the total. Timber panels were revarnished, upholstery replaced, wheels reprofiled, but the fundamental structure remained intact. The frame that left St. Rolox in 1896 was still carrying passengers without modification. The 1920s brought electrification and faster schedules. The Caledonian carriage was refurbished with electric lighting and upgraded suspension. The beauty of bolted construction revealed itself. New equipment mounted to existing brackets without cutting or welding. Pneumatic brake systems were retrofitted by drilling new bolt holes without compromising structural integrity. A welded frame would have required complete rebuilding. Through the 1930s, economic depression, when railways couldn't afford new stock, these Victorian carriages became invaluable. Their modularity meant repairs could be improvised from salvaged parts. A damaged underframe section could be unbolted and replaced with components from scrapped carriages. Modern welded construction offers no such flexibility. Damage beyond weld repair means scrapping the entire vehicle. World War II tested everything. The carriage survived bombing raids that destroyed stations around it. Shrapnel damage to body panels was repaired by unbolting perforated plates and installing patches. Had the frame been welded, the thermal stress of torch-cutting repairs would have introduced the very microfractures that now plague modern rolling stock. Post-war Britain saw massive railway rationalization. Thousands of carriages were scrapped, but the bolted Caledonian vehicles kept running. Their frames showed no structural fatigue. Bolts that had been correctly torqued in 1896 remained tight in 1956. Engineers began studying these survivors, trying to understand why they outlasted supposedly superior welded designs introduced in the 1930s. The answer was uncomfortable. Welding had been adopted not because it was better, but because it was faster and cheaper to manufacture. A carriage that could be welded together in days undercut one requiring weeks of bolting and riveting. Accountants saw reduced production costs. Engineers saw reduced operational lifespan, but accountants controlled budgets. By 1965, the Caledonian carriage had outlived 4 generations of welded successors. British rail engineers documented the phenomenon. The bolted frame showed no fatigue cracking, the primary failure mode of welded structures. Every joint could still be disassembled and reassembled. The vehicle was 70 years old, but structurally sound enough for another 70. Yet economics prevailed over engineering. Maintaining bolted carriages required skilled labor, men who understood torque specifications and bolt grades. Welded carriages could be serviced by less experienced workers with cutting torches. The craft knowledge that built the Caledonian Railway was disappearing, replaced by welding certificates and NDT inspectors searching for the cracks that welding inevitably produces. The last Caledonian bolted carriage was withdrawn from passenger service in 1968, 72 years after construction. Not because the structure failed, because the railway no longer employed craftsmen who understood it. Several survive in preservation, their frames still tight, still repairable, still demonstrating the engineering philosophy we abandoned. Modern train carriages are designed for 30-year lifespans. Welded aluminum monocoque construction saves weight, but introduces corrosion and fatigue issues impossible to repair economically. When structural cracks appear, and they always do, the vehicle is scrapped. We've gained speed and initial cost savings. We've lost permanence and long-term value. The Caledonian Railway carriage stands as uncomfortable evidence. Victorian engineers with crude materials and hand tools built transportation infrastructure that outlasted space-age alloys and computer-controlled welding. They built for their grandchildren. We build for next quarter's earnings report. The bolts tell the story. Each one individually placed, torqued, inspected. Each one removable, replaceable, eternal. Modern engineering has lost something profound in the pursuit of efficiency. We've forgotten that the cheapest option over 10 years is often the most expensive over 50. In preservation museums across Britain, you can still see them. Caledonian Railway carriages with their original bolted frames, structurally sound after 130 years. Next to them sit welded carriages from the 1960s, already suffering structural degradation after 60 years. The comparison is devastating and instructive.